lengths of the sides. You could graph it if you want. You don't have to graph it. I'm gonna like sketchy graph it, meaning I'm not really gonna mark it. I'm just gonna kind of go in this general area. 0, 4, I'm gonna say that's A, and then 5, 4, I'm gonna say that's B, and then -3, -2, I'm gonna say that's about here. Why am I sketching it? Because remember, if you have any horizontal or vertical lines, you don't necessarily have to do the distance formula. You could, but when you're here at 0, 4, and you go to 5, 4, right, you're at the same y value, you can just say, how far is it from 0 to 5? 5 units, so that's where you can get 5 for AB. But to do the other two, you're supposed to do the distance formula, and for sure, I'm going to make you do the distance formula on your test on at least one problem, because I had it on the quiz, and lots of people missed the distance formula. So you've got to know that to do the distance formula, you're taking the square root of subtracting the x squared plus subtracting the y squared. It doesn't matter what order you subtract them in, because you're squaring it. It just matters that you subtract and you square. You add it to subtracting and squaring the others. So if you do BC, I'm going to have the square root of 5 minus -3. When I have minus negative, I always make it a plus. And I'm going to add that to 4 minus -2 squared, which gives me 8 squared, which is 64, plus 6 squared, which is 36. Oh my gosh, that works out awesome. That works out to be perfectly the square root of 100, and the square root of 100 is 10. And then AC, I'm going to do this one. That would be the square root of 0 minus -3 squared plus 4 minus -2 squared. If I give you a question like this, I'm going to say verify or justify, meaning I want to see this. I don't want you to just graph it and say, well, they look all different, right? Like, I want you to show me how you know it means. Just like on the quiz, I'm probably going to write you a hint that says, yes, that means you do this. So on this one, we get 9 plus 4 plus 2 is 6 squared is 36, and that's the square root of 45. So how did they get 3 square root of 5? They did that whole simplifying radicals. So on the test, if it's a multiple choice question, it's probably going to simplify the radical. If it's not multiple choice, if you left it as a square root of 45, I probably count it right. If you simplify it correctly, maybe I'll give you a bonus point. We need to review this, because we should remember how to do this, but it seems like it's been a while and most of us forget. How do you simplify a square root? You think of two numbers that multiply to give you 45. One of them has to be a perfect square. Maybe. Yeah, the square root of 9 times the square root of 5 is the square root of 45. So that's how they got this, because the square root of 9 is 3. And then you can't take the square root of 5, you leave it in the radical. And that's your simplified thing. Remember the quadratic formula that you did with Miss Phi? I know you remember it. You did this with distance formula. Know it. What about 3, 4, and 5? They kind of are all dependent on each other, right? Because if you solve for x wrong, you're going to miss the other problems. But you got to know, what do you know about these two angles right here? And then if you solve for x, you should get 20. If you didn't get 20, that's why you missed the rest of them, because you have to take that and plug it in to solve for angle 1. And then if you know what angle 1 equals, and you can plug that in to find the other angle there, you can subtract from 180 to get the third angle, which is called angle 2. Questions about any of that? Did you get those right? Are you awake? I told you didn't have to do number 6, right? You know what I mean. You did all those distance formulas? Or you could have just, like, wrapped it all. Anyway, we didn't talk about that. Do you remember in some grade talking about reflections and rotations and translations? Chapter 9 is all about that, and we'll talk about it in detail there, but we're just skipping this one. What about number 7? Did I tell you to do number 7? Or did I tell you to do number 6 and skip number 7? Which one did I make you do? So number 7 says, determine whether triangles are congruent, explain. So that's the whole distance formula thing again. So on this one, you should have been able to show that the sides were all congruent. So GH and JK should have both equaled the same thing, which that's the same as the square root of 20, if you got the square root of 20. IG and LJ were also both the square root of 20, 2 square root of 5. And IH and LK were both 2 square root of 2, or did anybody get that square root? Square root of 8. It's 2 square root of 2. That was a lot of distance formula as well. And then you were supposed to say, how do you know they're congruent? Well, by side, 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 because you could show that the corresponding sides all were congruent. You don't know anything about the distance formula. I'm probably just going to give you one question on distance formula, because either you know how to do it or you don't, right? Why give you a lot? What about number 8? This one I could have said, you do a proof of this, but like if it was my test and not the book test, it would say do a proof of this. But this one just says, how do you know they're congruent? If they give me parallel lines, what am I going to have to be looking for? What are they trying to tell me if they tell me 2 lines are parallel? Alternate interior angles. Every time they want you to use those. So the fact that this line is parallel to this line, look for the transversal, right? So this transversal is cutting through here. So could I say this angle is congruent to this angle? Because that transversal, those are alternate interior. Could I also say, is A and D also congruent? Are those also alternate interior? Not the same parallel line, right? What else do I have? Okay, that's all the lines. You guys go all over your paper. I don't know why it helps me, the lines, to like make those lines go out. What about this? If I extend this line with this line, where's the transversal that goes through those 2 lines? Right here? So I think we could do those angles, right? Like this angle, this angle. So the alternate interior angle. And then, we got 2 angles. This was alternate interior, and this was alternate interior. And what else do they tell me? AC is congruent to FD. So you have to say angle, angle, side. I don't think we have anything else we could use to find the other angles. Like we don't have another transversal. So by this picture, angle, angle, side is the only option that you could do there. Here's my big hint for you. If any problem tells you that in a triangle that lines are parallel, you're going to be using alternate interior angles. Every time. They're not going to tell you they're parallel so that you can use your reflexive property. Or so you can use the triangle sum theorem. They're going to tell you they're parallel because they want you to find that transversal and they want you to use alternate interior. So those are things you got to look for. Okay? I'm not giving you any proofs tomorrow like this where you have to fill the blanks in. I'm giving you proofs where you just have to work them out. Which means they will not be 8 steps long. This one they make extra long because they broke their givens up into 2 statements. It's kind of nice when they do this because then when they break the givens up, they know like that's the given they're using for the statement that they want you to do. So they tell us that ABC is isosceles, that AC is the base, D is the midpoint, and we want to prove that BD bisects angle ABC. So they start with their given, and if you know your triangle is isosceles, then you know by the definition of an isosceles triangle that the sides are congruent. That's definition. But then, how do you know that the angles are also congruent? That was the new theorem from 4.6. If the sides are congruent, then the angles across from them. So the only answer that would work on number 9 is isosceles triangle theorem. Anything else is not the right answer. And then they use the given that it's a midpoint. If you know you have a midpoint, right? Again, if they tell you a midpoint, you know you can say that this side is congruent to this side by the midpoint theorem. And that's enough information to say side angle side. If you were writing your own proof, what else could you have said about that if you didn't notice the isosceles triangle part or the angle part? Did you prove any other parts of those triangles congruent? Yeah, BD is congruent to itself by the reflexive property. So if you were writing your own proof, you might have put that in there and not needed all that other stuff. But by what they did for question 10, you had to say side, angle, side, because the angle was in between the two sides. And then if I ask you to prove something, but it's not proving triangles are congruent, how do you know that angle 1 and angle 2 are congruent? Because the triangles are congruent, because corresponding parts of congruent triangles are congruent. And if you forget that on the test, you forget the silly letters, you can say, because all the parts in congruent triangles are congruent. Like, that's what that stands for. It's just a shorter way of saying it. So don't get freaked out if you forget the letters. And so definition of angle bisector says that BD bisects it. Your proofs on the test will not be that bad, and I'm going to give you some proofs in a minute to work on. Alright, what about that? I told you you didn't have to get over 12. I put the answer here, but just in case you wanted to take a look. But number 12 is not on your test. Nothing like number 12. Number 11, definitely something like that. Using equilateral triangles, knowing that each one equals 60 degrees, or knowing that all three together would add up to 180. Either way, you should have got that answer there with the algebra. Whoa, did anybody do that for 13? Is the hypotenuse leg congruence for right triangles? A wood column is supported by 4 cables that form 4 triangles. Determine which postulate can be shown that all the triangles are congruent. Did you even learn that theorem? I feel like that's a theorem that we haven't learned. Maybe that was a little extra one. What you couldn't say here, if you look what's marked here, what's marked in this one? Side-side angle? Is side-side angle an appropriate thing to write down on our test tomorrow? No, right? Side angle does not work to prove that two triangles are congruent, right? You don't want to write it in the other order. You don't want to put the A in the front, right? You don't want that on your test. What's the other one you're not allowed to write down? Yes. What's the other one? Angle, angle, angle is the other one that does not prove that two triangles are congruent. So make sure you don't put those on your test. This one, the hypotenuse leg congruence theorem, let's figure out where that comes from. I don't know what section. What does that theorem say? It says right triangles. If you know the hypotenuse in one leg is congruent to the hypotenuse in another leg, that the other side is also congruent. Which means you could say, we know that those sides are also congruent, and then you could use it again. You could use side to side, you could use side angle side. Oh look, it's on page 282. There's just this whole list of things. I will but it just says that if you know in a right triangle, if you know two sides of a right triangle are congruent to two other sides of a right triangle, then you know that the third side is also congruent. Only true for right triangles, not for anything else. I won't put anything like that on your test since we didn't really talk about it. But page 282 talks about that if you want to look at it. And then what about the bonus? Did anybody attempt the bonus? It's been out of control. If I was doing the bonus, I would have to separate it, I think. I'd have to redraw it in separate pieces. But it says ABC is isosceles, ADC is equilateral, and the measures of angle 9, angle 1, angle 3 are all equal by the measure of the numbered angles. What else? I don't know. I won't waste time with that. I'll look it up. But that's just want to do some proofs. And you have 5 proofs on your test. You know that, right? It's the worst thing. Okay. Fun stuff. Chapter 9. There's actually, when we get to when we get to trigonometry, which kind of sounds silly to say when we get to trigonometry, but it's kind of, I think that's fun. I mean, my definition of fun in math and your definition of fun in math are different things. But it's not proof. It's like working things out and solving something. The right triangle trig is probably the most applicable, the thing that you can use outside the class the most. Meaning that people that build things are using right triangles all the time. And using, I've had someone call me before talking about roofing their house and trying to get the slope of the roof a certain degree so that it's not too steep, but it's steep enough. Using trig to do that. And I was drawing the triangle and so it is kind of something that's more useful, I think, but I can mess with a lot of stuff. Let me just slide you guys out. That makes sense. Am I lying? Here's the thing. Some of you are never going to like it, no matter what I do, right? Like, the only time you would like it is if I like did extra homework and then I grade proofs and if we just like do this. Right? But that's not gonna happen. I'm just gonna give you someone something for people that want to do this. I'm writing down page numbers with problems. Tell you what to look at. You want to practice first. We'll do one and then after, right? Once there's people that aren't here that might watch stuff that also, if you don't want to do these, a great thing to do to study is practice ones that we've done together. Practice proofs that you have notes for, that you have worked out, that you could try it, and then you could look at the answer and see how to do it, right? People always say, how do you study for math class? Here's how you don't study for math class. I studied for 2 hours, is what you do. Right? Like, that's not studying for math. Studying for math is practicing doing the types of problems. Not staring at your notes that are already done for you. Redoing problems that you know are going to be on there. That's how you study for math. I took this class in college, and the problems were like a whole page, and the way that I would study is I would write the problem down, I would work it out, and then I would open my notes up that we had worked it out in notes, and I would check, does my work match my notes work? And if it doesn't, what did I do wrong? So that I know how to do it. And then if I got it wrong, I do it again until I got it right. Because that's how you have to practice math. Yes, you can read over your notes. Yes, you can look at your theorems. But if you just stare at proofs that are already done for you, that's not going to help you at all. Alright, you have to practice doing that. So I'm going to do it, okay? So you're going to do it. Listen. Ready? totally different. These are my suggested study lines. This is just one we're doing. And remember on the test, I'm not going to make you do one kind of proof. If you want a two-column proof, you do a two-column proof. If you want a flow proof, you do a flow proof. If you want a paragraph proof, you do a paragraph proof. Whichever way you want to do it. I like two-column proofs because that's how I'm going to roll. That's how my answers look. Then I would look at yours. Yeah, it's your choice. It's just going to say proof. Probably I'll say proof by one of the three methods, just to remind you that you can't do it. So I'll take the rest. Did you write this down? Are you going to do it on there? The great thing about your test is that you can write on it, right? You can draw on your picture. Every time I write a proof and I write something given, if it's not marked on the picture, I mark it on the picture. Because I want to see. If I'm trying to prove triangle right through it, I'm trying to prove side by side, side by side. Angle side angle. Angle side. That's alright. That happens with my son. Right, so the first one is always our given. If you really want to spread out your given as two separate things, you can. Interesting. So they tell me that AB is parallel to DC, and they also tell me that AB is congruent to DC. So I have one side. If I'm trying to prove triangle is congruent, I gotta find two more things, sides or angles, to go with that. It's gonna be one of the four things. What do you think? Do you know a side or an angle, or what is it, a side or an angle? What does it give me in the given? What do they tell me? This parallel. What did I tell you? If they give you parallel lines, what are you going to have to use? Yeah, there's going to be alternate interior angle somewhere. You just got to match it up. You got to find it. So let me change colors here. Here's my parallel line. There's two different lines that we could use as transversals, which means you could use one or both. Kind of just depends on what you see, but you got to at least use one as unfair. So what do we want? Do we want AC as our transversal or BD? AC? Is that what you said? So if this is my transversal, where are my two angles that I'm talking about? Right here? Right here? And the alternate interior angle would be right here, because they alternate sides, right? So we know, because the lines are parallel, that those two angles are equal. So I can say angle BAC, BAE, this angle A. We could just say angle A because it's not angle A is only one angle. So we could say angle A if we want, but can we just say angle C on the other one? You can't just say angle C on the other one because you see how angle C, there's really two angles of angle C. So I'm going to do, if we do three letters, A has to be in the middle. We could do B, A, all the way to C. Or we could just do B, A, E, since the triangle we're trying to prove is triangle ABE. That's what I would do. But both would be right. Or you could just say angle A. Like, just know that all of those are okay answers. This is probably why people hate geometry. Because we're all accepted it. then I'm going to say angle BAE is congruent to angle TC. Am I going to say that again? I might know. Because they're parallel? Or what do I write there? Because they're parallel. What kind of angles did it show? And if you really wanted to, you could draw that other transversal and pretty easily do the same thing. Okay, we don't want to. It's okay. There's another option here. I think. Is there another option? Oh yeah. We have a side and an angle. So what are the two triangles I'm trying to prove? I'm trying to prove that this triangle is congruent to this triangle. Can I prove that any more of those angles are congruent to each other by not using parallel lines? What other angles do I know? Okay? Yeah, what about this angle and this angle? Vertical angles, right? Reflexive is if it's the same side or the same angle, but when there's angles right across from each other, those are vertical angles, and vertical angles are always congruent. So you can either do that, or you could do these as alternate interior. Both are acceptable answers, just it changes how you're going to prove it. I'm going to go with say angle A, E, B is congruent to angle what? And remember that order matters. And a really great way to help you, I always look at this to help me. So I said A, E, B. So I went first, third, middle. So I know that that has to be C, E, D, because they all have to match up, right? As corresponding parts. So, and so some people, I'm not a good visual person sometimes. So I go back to this, but if you can just look at it on this, that works too. And this would be because of the vertical angles. You just said vertical angles, that's okay. If you have three things, as long as it's not angle, 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 or angle, side, side, you've proved it, right? We have a side, we have an angle, and we have an angle. So most of your proofs tomorrow should look like this. This would be about 4 steps. And we could say triangle ABE is congruent to triangle, and we're not going to say proven, I'm not going to say CPCPC, that's only used if we did want to prove the side, for example. What are we going to say then? How do we prove that? Yeah, we have two angles and a side not in between. We have angle, angle, side, or side, angle, angle, however you want to say it. It's different than if you said angle, side, angle. If you would have done the other alternate interior angles, right, that would have been down here. That would have been angle, side, angle if you did it that way. Interesting to do these. I think that might be all the angles that are missing. How could you find angle 1? That's the only thing they tell us on this. This is the only thing they tell us, right? That this side is congruent to this side. What kind of triangle do I have going on here? It's a little isosceles triangle inside this bigger triangle, yes? So what was the new theorem we learned about isosceles triangles? If the sides are congruent, the angles, which angles? The two that are across from the sides are the same, right? So 66 degrees, this one, so what other angle do I know? It's 66 degrees. Like this red triangle is the isosceles triangle, right? So angle 1, angle 3, 66 degrees. One of those other angles has to be 66 degrees because it's an isosceles triangle. Is it angle 1 or is it angle 3? They look the same. It's never an appropriate geometry response.
We might actually measure it.
We can't measure it. Which angles are across from the sides? This side goes to this angle, yes? Which angle does this side go to? Right? It's the angle across from the side. Draw the line in if it helps you. So angle 1 is the same as angle 66 because they're both across from the sides of the thing. I think you have to start with angle 1. I don't think you can start with any angle. I don't think you have enough information. But if you get that angle 1 is 66 degrees, yeah, so now we can say that the triangle. But you gotta find that starting point. Don't make up that starting point, okay? So now that I know angle 3 is 48 degrees, what else could I find? Because what do I know about 3 and 4? They're a linear pair, which means we can just take 180 minus 48. Also, while back, very beginning of chapter 4, we learned that exterior angle theorem, right? Angle 4 adds up to those other two angles too, so it doesn't repeat that. But either way you get angle 4, you should get 130. 6 or 180 minus 48. The whole 180 that you get, so 132 plus 24 is 156. Subtract 180 and you get 24. Definitely going to see a question like that on your test tomorrow, where you have to figure out where to start, solve for missing stuff. Okay? What else? Tomorrow is the last day to retake homework quizzes, yes? So don't forget to do that. You get your midterms Thursday, which means if I can be super on it and grade your test, those could be on your midterms. So we'll see. Depends on what time they print the midterms, I guess. If they print it Wednesday afternoon, it's probably not. But we're only gonna have one more test after this because the school's crazy. Isn't that crazy? Don't forget that your homework's due tomorrow. So let's talk about what your homework is due. Practice proofs. But also look at your chapter book quiz and like I feel. That's what I'm figuring out right now. I have like you should have 6 homeworks from your book. Then you also have a quiz review worksheet that's just one-sided, I believe. And then you also have this review worksheet that we just went over of chapter 3 test review. Chapter 4. The quiz, does anybody have the quiz worksheet? So I believe you should have 8 total assignments that you turn in to me tomorrow. So not much time left in here today. But you want to try to get that together so that you get started your test tomorrow. Look over your theorems so that you're kind of aware of them. But the big thing, if you're looking for something to practice tonight, practice the I wrote down the numbers up there, or just practice ones that we have done. Just go through and pick odd proofs from the homework that you can look at the back of the book and practice, because probably proofs are going to be like 5, 30, 35 your text. Okay. So you can't like, right? I promise that maybe settle down a little bit after this, but it's really important. So, to get what after guide, it's also all about time. So, and then starting next year, we're getting to polygons and rectangles and parallelograms and trapezoids and all of that. Right? I'm still recording.